All right, let's jump right into this. Welcome to today's explainer. Today, we're going to fundamentally reframe how you think about the words you speak, type, and read every single day. We usually think of language as just a list of definitions in a dictionary, right? Static, flat, maybe a little boring. But what if I told you that inside your mind, language actually behaves exactly like a quantum physical system? Seriously, prepare to have your perspective shifted, because the words you use are far more dynamic than you probably ever realized.
Okay, let's dive into this with a deceptively simple question. If I just say the word bank to you out of nowhere, what does it actually mean? I want you to notice what your brain is doing right this exact second. As you try to process that one simple sound, your mind is literally pulling up two totally different realities. On one hand, maybe you picture a bank, vaults, ATMs, tellers, but on the other hand, you could be picturing the muddy edge of a river with reeds and water flowing by. Those are two completely distinct universes of meaning attached to one single phonetic sound.
Now, linguistically speaking, this is known as polysemy. It's just a fancy way of describing a phenomenon where a single word carries multiple meanings. Pretty standard concept, right? But look, we aren't here for a basic grammar lesson today. We're actually diving into the mathematical mechanics of reality. Let's look at how our source material mathematically defines this.
And boom! Polysemy is formalized as the coexistence of multiple stable interference patterns. That quote, it's pulled right out of the opening comments of the source file we're analyzing today. Yep, we're suddenly pivoting from English class straight into quantum physics. The idea here is that language isn't just ink on a page, it's an active system of interacting waves.
So let's take a look inside the actual lean file, polysemy as multiple waves.lean.
I know, it's kind of wild. We are diving deep into a hardcore, computationally verifiable mathematical proof written in Lean, which, if you're not familiar, is a functional programming language and interactive theorem prover. This file literally uses strict math structures to prove that human semantics follow wave mechanics. It sets the foundation by treating semantic domains like finance or emotion or geography as literal mathematical frequencies. Words are defined as standing waves vibrating in that space. And the really cool part? It proves that context acts as an external frequency, determining which waves remain stable and which ones collapse. Let's break down the 5 mathematical theorems it lays out.
Theorem 1. Metaphors are constructive interference.
Moving to Theorem 2, ambiguity is destructive lock.
Now, what's really interesting here is what happens when meanings clash. If Theorem 1 was about overlapping frequencies creating beautiful metaphors, Theorem 2 tackles ambiguity. The code defines a structure called an ambiguous context, where two meanings are fundamentally incompatible. They just absolutely refuse to collapse. They enter a state the proof calls a destructive lock. You know that feeling when you read a sentence and you're totally torn between two interpretations? Your brain just feels stuck? Well, according to this formal proof, your brain is actually experiencing the literal mathematical tension of two standing waves refusing to cancel each other out. How crazy is that?
Next up is Theorem 3, the frequency of meaning.
This is where the math gets incredibly specific. The code separates obvious everyday literal meanings from poetic metaphorical ones using a hard numeric threshold. And that magic number? It's 10. The source code explicitly uses the number 10 as the mathematical cutoff for a semantic context frequency. Let me show you exactly how it applies this.
So, the crucial point to take away is this. The file defines a literal meaning as having a context frequency of less than or equal to 10. It's a low-frequency wave. It's the obvious, direct sense of a word. But a metaphorical meaning, that is strictly defined as having a frequency greater than 10. Because it operates at a higher frequency, it literally requires more cognitive energy, more context for your brain to resolve it. Literal is like a low hum, while metaphor is this high-pitched vibration that just needs more work to decode.
All right, Theorem 4, compositionality is superposition.
So how do words actually combine to form a full sentence? Through superposition. Much like in quantum physics, a phrase is proven here to be the linear superposition of its component word meanings. When words align properly, the amplitudes of their individual standing waves literally add together. The whole phrase's meaning is just the sum of these wave amplitudes interfering constructively. It is, mathematically, well, it's just elegant.
And finally, Theorem 5, polysemy collapse.
This theorem models that exact satisfying fraction of a second when a confusing sentence suddenly makes sense in your head. And this brilliantly illustrates what's going on behind the scenes. Look at this distribution. As context arrives, one dominant meaning phase locks with the context through constructive overlap, taking over 85% of the space. Meanwhile, all the alternative realities undergo destructive cancellation, getting suppressed all the way down to 5%. You aren't consciously choosing the right definition. The surrounding waves are mathematically crushing the incorrect definitions out of existence.
Let's bring this all together with the 5 steps of semantic resolution. Basically, the proof gives us a complete mechanical algorithm that your brain executes in milliseconds, hundreds of thousands of times a day. Let's see how this builds. Step 1. A word hits your ear, carrying multiple standing waves of meaning. Step 2. The context of the conversation kicks in, imposing a specific frequency. Step 3. One meaning phase locks with that context. Step 4. All other incompatible meanings destructively cancel each other out. And finally, Step 5. A single, crystal-clear meaning emerges into your conscious awareness. It is this perfect, rhythmic, mechanical collapse of a quantum state.
Which brings us to the big picture: why words are waves.
You might be wondering, why go through the immense trouble of writing a complex lean math file just to prove this? Well, because it proves that language isn't just a static dictionary. It is a wildly active quantum landscape right inside your mind. Our daily conversations, the texts we fire off, the poetry we read, they are all governed by the exact same laws of interference, amplitude, and frequency that govern the physical universe. Your mind is constantly juggling these overlapping waveforms, stabilizing some realities and destroying others just to understand a simple sentence.
And that leaves us with one incredibly profound thought to ponder. Every single time a word phase locks into a clear meaning, dozens of other potential meanings are forced into destructive cancellation. If our spoken words are truly just quantum waves collapsing into a single shared reality, what happens to all those other frequencies? What happens to the vast oceans of meaning we suppress just to be understood? Think about that the next time you speak. Thanks for joining me for this explainer, and keep questioning the realities right in front of you.